Hey there folks, welcome back to another part of my thing where I am making a Tetris Game Analyzer. Well, last time our Game Analyzer proof of concept took a bit of a larger scope and we added Tetris rate to it. That was super fun. That's a statistic that's not kept in game, but is well recognized by the community as a very important statistic. So today, actually last time after we did the Tetris rate, and you can go back at the end of the last video and watch us go through that, I did some offline testing just for kicks, just playing some Tetris and watching the Tetris rate work, and it actually works very well. I didn't notice any issues with it, and so that's exciting. But we are hindered by the fact that our game analyzer is not fully fledged yet, and there are issues, most notably when the game ends, your score is detected to be 88888, right? And your lines are 888, and your level is 88, and the reason for that is because the game is over, and you're usually, if you get more than 32,000 points, you're on the rocket ship screen. And that screen is bright colors all around, and most of it's bright blue. And if you remember our algorithm for detecting a digit, we look at the non-black pixels and compare it to each digit. And so with a fully blue background, every pixel is non-black. And so it will match the digit that's made up of the most number of non-black pixels, which just so happens to be the 8. And the 8 fills out its box the most of all digits. So that's not so fun because the Tetris rate is based on Tetris, getting a Tetris, and getting a Tetris is based on what were my lines last time versus what are my lines now. If it's more than 4, if it's equal to 4, then I just got a Tetris. And as you can well imagine, an 888 throws everything into chaos, not to mention that the game is over and we want to restart from 0. Anyway, when we start a new game. So what I'd like to do today, the goal today is to come up with a way to allow the Tetris Tools program to run continuously and detect when a game has started and when a game has stopped. And when the game stops, reset the data. The way I see it, we've got 4 levels of data that are important to us, that will be important to us. We have the data on a current screenshot, data for the current game, data for the current session of games. You know, I want to sit down and play 10 games, and maybe I want to calculate what's my top score, my average of my top 3, or something like that. And then a 4th is historical data. Maybe I want to keep track of like the best run of 5 games I've ever done, or something silly like that. So in order to have the session actually play out nice, we have to be able to detect when we started to play and when we stop. And when we stop, then we can detect when we start again to zero everything out. Full disclosure, I've been thinking about this and I'm not entirely sure how to go about this. But that's what today's all about, coming up with a way. So here's some things about Tetris. Let's just get Tetris running here. A few things we have to keep in mind. It's Christmas time. VLC's got a Santa hat. How nice. Let's get this here. So here's the Tetris title page. This is the music select screen. This is the level select screen. We can select the level and we can just select level 15. Now we're in the play screen. And the thing is, if you get there's a certain threshold of points that it will go right from the game screen to the level select screen if you don't get a certain threshold of points. Now, if you do get a certain threshold of points, and I believe that threshold is 32,000, but let's just have a look here. I think it's 32,000. Let's get a triple and see what happens. No. Just build up for a Tetris here. I mean, you should probably be familiar with the Tetris, the rocket ship screen anyway. There we go. Okay, so now I got 44,000. Now if I go ahead and end my game, because I got more than 32,000 points, it's going to send me to this rocket ship game. And now all sorts of things are haywire, because this is what's detecting the 88888, and yeah. So after a game is done, there's two places you could go. You could go to the rocket ship screen, or you could go to the, oh yeah, and then once, that's another thing. So if you get a high score, you also get to enter your name. And the high score is if you're in the top 3 scores this session. Okay, a Nintendo cartridge doesn't have an internal memory. You can't save high scores between power-offs. A reset will keep the scores, but a power-off will lose all your scores. Anyway, so if you, yeah, that's actually a third scenario. If you don't make 32,000 points, but let's say you made 16,000, you're going to go to this screen, the level, the high score screen. So let's do that. Let's make sure we understand that. And I think I can do that by getting just one Tetris and then topping out. So one Tetris gets me 19,000. Oh, no, let's not pause. That's another thing we have to worry about, is pauses. So now I didn't get 32,000. That means no rocket screen. But I did get past the second player, Howard, who was at 10,000. So now I went from the game screen to the high score screen, or you go from the game screen to the rocket ship screen, or you go to the game screen just to the level select screen if you didn't get 32,000 and you didn't get one of the high scores. So that's exciting. So rather than try and figure out all those scenarios, the only thing I can think of is that we need just a single way of determining if we're currently playing or not. And we can just ask the question on every screenshot. Are we currently playing? And if we're currently playing, go ahead and do all the Tetris data model stuff and update the game model and all that fun stuff. If we're not playing, start into a loop and just check every second, and only start up determining data again once we're playing. So there's a single check I want to figure out, and that is, are we currently playing Tetris? And this is going to be an issue because I don't know how to do that. So like the level select screen, okay, the game screen, let's just get some, how do I take screenshots? I did this before. Video, take snapshot. Okay, so that's playing the game. Let's get to the, this is when your game ends. I think that we'll treat that as the same screen. The level select screen, we'll want that. Take that snapshot. Let's get, oh, this is level 5. Whoops. I want examples of all screenshots. So let's do some 18. And we'll try and get on the rocket ship screen. And a high score, because that's fun. One more Tetris ought to do it. So now we're at 53,000. Should be good. Well, not just should be good, it is good. So why am I still playing? Because I'm set up for the Tetris, man. Gotta get that Tetris. There's nothing that says you need to get that Tetris, though. Okay, so I'm ready to take this screenshot. The rocket ship screen. The high score screen. Okay, now what else do I need? I need to reset this. Get the intro screen. The title screen. The music select screen. And I think I got the level select. So 1, 2, 3, 4, 5, 6, 7. Okay, let me take all of these, throw them into another folder here on the desktop. Okay. And now we're just going to have to look at them. These are all the different screens. We need something that is different about the playing screen from every other screen. So the first thing I see, there's a lot more gray than the levels, or so the high score list and the level select screen are both the same, except this is colored. This box is colored. And the other thing we need to do is I want this check to be as fast as possible. Because if this is not fast, we're going to spend a very inefficient use of our time trying to figure out if we're currently playing. I don't want that. I want to do a quick check. Are we playing? Okay, we're still playing, so let's calculate data, or no, we're not playing anymore. So let's save the data and reset it all. So those two screens are the same, more or less the same. They're the same shape. They have the same look to them. A big black box in the middle with some text. Now the rocket ship screen is mostly blue. This screen is mostly black. And the thing is, we can't, like, one of the naive things to do would be to say, oh, well, just look at this specific spot, you know, if there's a 1989, then, you know, you're in the title screen. And that's okay. I mean, actually, that might be a way of detecting the title screen. But if you go back to our algorithm about how to detect a digit, the digit is assumed to be one of the 10 digits. That's why an entirely blue square is interpreted as an 8. It's got to be one of the 10 digits. So we can't see, oh, is this part of the screen a 9 or not? I mean, it's going to be interpreted as something. And it could be that it's interpreted as a 9 when it really isn't a 9. So I want something more specific. And we can't really go with color because color varies. Because this is an RGB video, it's an old Nintendo, an old capture card, colors are going to fluctuate. And I don't want that. The level select, or the music select screen is mostly gray. Okay, what I want to do is I think we're going to open up GIMP and try and do some GIMP magic. I thought of this yesterday. Sorry, we're not going to be doing much coding today because I knew we would have to do this eventually, but we're not going to be able to make very good use of our game analyzer if we can't figure out the boundaries of games. So actually, I don't want to open up. That's the last one I want to open up. I want to open up this one. Tools. How do I make an image opaque or transparent? GIMP make layer transparent. Actually, decrease opacity. GIMP opacity layer. How to make semi-trans, yeah, layer masks. Okay. Right click, add a mask to the, okay, whatever. Right click, add layer mask. Ha. Channel? What is it? Oh my goodness. This is nightmarish. Here, you know what? You know what we're going to do? We're going to say select by color black. Edit. Clear. I know how to do that. Select none. Perfect. Okay, and then we're gonna image, file, open as layers. Actually, okay, that's fine. We're gonna select by color, black, edit, clear, select, none. Okay. Now we're gonna open as layers. See, this is fun stuff, isn't it? Select by color, clear. Wait a second, that's not what I wanted. That's what I wanted. Okay, select none. Okay, so now we'll open layers, this screen, add an alpha channel, select by color, black, delete it, select none, file, open as layers. Woohoo, super fun. Select by color, this. Oh, I need to add an alpha channel. Delete, select none, file, open as layers, this screen, select by color, black, add alpha channel, delete, select none. Here we go, folks. You know, I'm going to remove this. I want to delete this layer. Delete the layer. Let's open it up again because I didn't know about alpha channels. By color, black. No. Cannot subtract from an empty selection. Select by color. It's not going to let me. Okay, well, we don't need that one anyway. Now we can figure out what is different. But we do need the game screen in here. What? How did this one come back? Don't show that one, please. Select by color. Cannot subtract from an empty selection. Well, something's wrong. I thought this was going to help me. Okay, so we can compare now our game to all the other ones. The rocket ship, I don't know what's wrong. I can't even delete it. Something's happened. I don't even know. Doesn't matter. So here's my game screen, and this is the high score. So I'm seeing actually, look at the lines. The first digit of the lines. Will show as nothing. See, because that digit is not there. So that's actually going to show up as probably a 1. You know, with all black pixels, it's going to pick the digit that is the least. But actually, because we reduce it, we get rid of all the black pixels around, it would get rid of the whole thing. Guys, that's what's probably causing those strange exceptions. Oh my goodness, that's awesome. So that might actually be a thing. We might want to actually put that into our algorithm to say, if it's all black, don't keep looking. And then the digit itself, we can return like a non-digit, we can make the integer nullable, so we can return null. Anyway, that's an idea. I'm going to write that down. So if we get the level, the first digit of the number of lines, if we determine it's all black, we could be that's a way of differentiating the high score list from the playing list, from the playing screen. Now, this one, it won't work. So that's too bad. This one, that's not going to work either. Maybe there's no point in writing that down. This one is the same. Shoot. What if I look at them all? Can we see any black? We do see some black. Now, bear in mind that the middle of the screen could be filled with all of this black is not necessarily going to be black when we're playing the game, because we're going to have tetraminos in there. Look it up in the top left where it says game. There's some black there. So, I'm gonna have to do this in two different chunks. No, where's this one? Where's this one? Oh, what am I thinking? If I see black, that means everything's black all the way through. We might have to do this in a two-step check process. Now I'm looking at the level. So this will display a level. On this screen, that 5 is going to be all black. On this screen, it's either going to be all black, or if no, it's going to be an 8. I'm pretty sure that'll be an 8. On this screen, I mean, it's definitely not all black. This screen, it'll be all black. That's just totally bonkers. Actually, is this screen? It's a little bit. This screen is going to be all black. So if I look at the second digit of the level, and I see that it's not all black, I'm either playing or I'm on the rocket screen, or I'm on the game select screen. So I'm going to write that down using an old-fashioned pencil. Second digit of level. I'm either playing, I'm on the rocket screen, or I'm on the, that was the game select. Well, the title screen really isn't that great either. Play, rocket, or game select. So what do I need to differentiate the rocket and the game select. Well, on the rocket ship, but that's the one part of the rocket ship screen with black in it. That's not gonna give me an 8. Huh. This is a super boring video. This is the kind of I can't even think of the word. Boring work that is not very fun. Is there anything else? I don't think so. Okay, let's look at the next box here. So on this screen, that'll all be black. This screen, it's going to be mostly not black. This screen, that's not black either. Shoot. Black. Black. See, all of these. Okay, so this is all the screens. Interesting. Except the rocket ship. If I can see a piece of the playing screen, that means it's the only one that's not black at that point. Oh my goodness. Look at the top score. Why didn't I see that before? Oh man, there it is. You start with the top score. See, we can figure out the top score. It's the same as the score. We're good at figuring out the score. So if I looked at even the first 2 digits of the top score, if I get actual numbers back, I'm on the playing screen. Because at that position, this screen would show all black. This screen would show 8-8. So if I ever get up to 888,000 points, or in the 880s of thousands of points, this would no longer work. But a quick check just to make sure this isn't all a solid color. I think I can do that. This screen would show all black. This screen is going to show all black as well. This screen is different. We'll get back to it. This screen will show all black. So if I see a number here, I know I'm either playing. Again, it's the same thing as before, looking at that second digit of the level. I'm either playing, I'm on the rocket ship screen, although this time the rocket ship screen is a solid blue, so it's easier to detect. Or I'm on the game select screen. And I'm not even sure what it would show. I mean, it's going to try and interpret this. Oops. It's going to try and interpret this. Oh, come on. How do you, I don't even know. I don't even know how to draw a rectangle. Rectangle select. Cannot subtract from an empty selection. Select all. Select none. Whatever. I don't even care. GIMP's broken. Whatever. So I'd like to see how that gets interpreted. Okay, well, this has been 40 minutes of trying to come up with an idea. Oh, man. So my hope is that if I see, let's take a look at those 2 digits of the score. The other thing is, if I ignore this screen, it's easy to tell this screen. You know, in that position, it's going to be 8-8. So I can just make a check, you know, if those show up as non-88888 numbers, I'm either on one of these 2 screens. And then, I mean, just to differentiate these 2 screens, shouldn't be that hard. I could look for an all black square up here. Whoops. I'm just concerned about the 88888. That's okay. I mean, we don't have to solve all the problems with this in one shot. You know, we can iterate on this. So let's finish the coffee. And get more, because that's the important thing to do. Let's get to work. So the one thing I need to do here, I'm going to open up this one in another thing so I can like select things. Mode. Cannot, for crying out loud. I don't even know what is happening to my brain. Come on. Everything's breaking. Why can't I type? Oh my word, you guys. 1 second. My keyboard just... What is happening to my brain here? Here. This works. Yeah, okay. Did my keyboard literally just run out of batteries? Seriously? No, I don't think so. This is working just fine. What's happening? Okay, 1 second. Computers are dumb. Typing. No, I can't even type still. Can I even? Well, I can't even type with my laptop keyboard. What's going on? Cancel. Close. Close. What is happening? I don't get this. Okay, whatever. I don't even know. I need more coffee. Yeah. Okay. We need the... Let's get Visual Studio Code open here. And I want my... Game Analyzer, screen recognition. Where's my JSON file? Where's my JSON file? Data extract. What in the world is happening? I don't even know you guys anymore. Tetris data extractor. Tetris tools. There it is. These are my screen positions. So I think what I'm going to do is actually add top to this. And my X is going to be the same. The same X coordinate as my score. My Y, though, is going to be different. So here I had 145. So now I think I want, like, what do I want here? 88. Let's try 88. Now the width, oops. The height is 22. That's not a big deal. The width is, oh yeah, we're doing 21 digits per digit. So let's just look at the first two. I mean, I guess we can look at the... We can look at all 6 of them. I just don't want to waste cycles, so... Now let's just look at the 2. Nah, let's just do the whole stinking thing. Because at some point, I might want to. No, but that's not really fast. Here's my issue. If I'm going to call it top, I want it to mean the top. Like, I don't want top and have only part of the thing there. Like, it's not the top. It's a screen check at that point, and that's what it is. But I can't be... If I call it top and only take part of the top, that's confusing, especially for me in 6 months when I look at this again. But if I do the whole top, then I'm calculating the whole top again. No, I'm just going to calculate the whole top. And if I ever get an 888888 score, I'm in trouble. It breaks the algorithm. Not so great, but not that terrible. Oops. So because we're adding these screen positions, what we're going to do is we have to go into the data extractor, the Tetris data model. And we have to the Tetris data model is going to have a new property, and its private Boolean is playing. Okay, and we will is playing we're going to get, I already know I'm not going to like this, but we have to start somewhere. It's playing oh, whoops, this needs to be, no, what, no. Oh, right, I have to value, it's a nullable, that's fine, okay. Is playing equals. Now, this is where the logic, do logic here, and return is playing dot value. All right. So, screen reader dot get value at. This is the screenshot positions. Now we can do the top. No, we can't do the top. Wait a second. Positions. Screen positions. We didn't add the top in here. Public rectangle. Top. Okay. Yes, I got it right. Top. We'll get the 6 digits of top. What's the problem here? Oh, yes, because this is an integer. What we need to do is we're going to make sure it's not equal to 888888. That's a key point here. All right. So that's good. Now that's a very naive way of doing this. But I think what we need to do, though, is go into, we're going to have to go into the deep bowels of our digit recognition algorithm. Because here's the thing, we're going to be reading sections of the screen that are all black. And when we reduce the image, if you recall, we find the first non-black row. Then we find the first non-black row. So basically, if it's all black, this method, because our algorithm shrunk the black space around a digit until that digit's bounding box was snug, right? But the thing is, if it doesn't find anything, like if it's a completely black space, finding the first black row and this is the reason, oh my word. I can't believe we figured this out. Because I was getting strange errors, especially when like it was not on the screen, right? The playing screen. So what we do here is we're trying to find the first non-black row. So we have the start. So we start at 0 and we go up by 1, and we're just checking each row. Is it black? Is it black? Is it all black? Is it all black? Is it all black? This is while it's not equal to found. So this is a while loop. It will go forever until it finds a non-black row. Problem is, this assumes we will find a non-black row. If we actually don't find a non-black row, so this is a fully black image, we are going to be getting the pixel at something that's way outside the bounds of the image. Because we'll start at 0, and then we'll go check the first row, the second row, the third row. You know, we're never going to find a non-black row, so we're going to start checking, you know, the 81st row. We don't have an 81st row. This is going to throw an exception. That's why the errors happen. And that's the source of those errors. And that's why I have the game analyzer. I put it in a try-catch block, because we're getting like strange exceptions at certain points, and that's awesome. We figured it out. Okay, so what I want is, I want the ability, no. Hold on, that's old stuff. I want the ability to recognize we don't have, you know, everything's all black. So if we reduce the image here, what am I doing? And we have to say is not equal to found. Or okay, this is what we have to do. This has to return an integer, a nullable integer. Okay. If you can't find any row, if you cannot find any row that's non-black, you don't have to check for columns. And conversely, if you have a black image, finding the first non-black row, I'm just thinking you don't have to do it both. You don't have to check for the first non-black row and then for the first non-black column. You just have to say, you know, you just have to do one check. Because if you can't find a non-black row, there's not going to be a non-black column. So we only have to do this once. Let me go back here and see what we're doing. If we reduce the image, we get a bitmap. Problem is, we might not get a bitmap. Oh, well, bitmaps are already polar value type. Reference types. What am I talking about? Okay, so here we go. I think we're going to do this old school. Okay, so we're going to say not found or current row is greater or equal to the bitmap's height. Okay, so if the height is 10 and we're on 10, we're outside of the bounds of the array because it's 0 through 9. Yeah, that makes sense. Okay. Return found the current row, otherwise null. Let's do this. It's nullable. All right. And I think we should do this too, even though we're not really going to do it, because we're just going to check for the row first. But these are independent methods, so you don't want your program dependent on calling methods in a certain order. You want the actual things, methods to be discrete, concrete. All the logic makes sense within them. You don't want them to depend on other things. So we're going to exit out early if this first non-black row method returns a null. But, I mean, nothing's stopping us from checking the columns first. So let's just do this. Current column is greater than or equal to bitmap.height. And I already see my error. This is width. Okay, so that's saved. So if we found it, return the current column, otherwise return a null. And that will work. So now these things return, null if they can't find anything. Okay. Int top, let's just go var. Now, if top equals null, then return null. And I know, there's some ideas that returning null is kind of bad to do. And it is. Like, we don't like that. You should probably return options. And you know what? We might do a session where we kind of introduce a functional aspect to this program. That's going to be in a big refactor. And we'll use a functional library written by someone who used to work at my company, who made a functional package for C# that, but he made it was made and given to the world, so anyone can use it. It's not under my company's code repositories and private. I mean, it was made public to the world, and it's what I use at work, and I like it. And anyway, it lets you return options and things like that instead of nulls, which is better. But for now, we'll just return null. Okay, top equals null. So bottom, we're going to do this. Left, we're going to do this. See, the thing is, if you find something scanning down from the digit from the top, you find a non-black row, you're guaranteed to find a non-black column, and you're guaranteed to find a non-black row coming up from the bottom as well. So we can do the dot values right here pretty safe. Dot value, not the best, but perfect. So now reducing the image is actually going to return null. If by reducing, the whole thing disappears. So that's kind of nice. Let's find out where we're using this. If reduced image equals null, return null. Well, let's return string empty. Now let's return null. We didn't find anything. Okay. So that's what happens when you get the digit. Now, here we use get digit. Now we actually might get a null. So, because we might actually get a null, we're going to make this return a nullable integer. We're going to say if digits dot values, actually we'll do it in here. If first we'll figure out the digit. If digit equals null, then not a number equals true. Let's do that. Is, well, let's just say, okay, hold on. Let's be reasonable about this. Var is valid equals true. How much time have I? Oh, I'm 109, over an hour long. We're not going to get finished here. Is valid equals false. And then we'll just say equals digit. Down here, we're going to say if is valid. If it's not valid, we're going to return null. Otherwise, we're going to return all this stuff. We can actually combine this. We can say return is valid int.parse string.join digits order by kvp key value pair. Yikes. Order by kvp kvp.key dot select kvp kvp.value, and you're done. Otherwise, the null version of an integer. There we go. Okay, final number. What is going on here? Yeah, we never really use it anymore. Okay, so now this get value at will actually return a null if any digit it found was totally empty. Okay. I have some errors here because this is now an int, a nullable int. And all of these now, oh, interesting, they all still work because the private variables were always nullable. Oh, shoot. I think the solution is to make this equal to -1. But we're going to have to stop it there. I mean, life needs to continue. So we're going to have to stop it there. Hey, that's what happens. We're just going to make sure that our work is all saved. Save all. In the middle of testing for play. Perfect. Push that up to master. Okay, that's it. We're done for the day. Next time we're going to dive right back into this and continue it in hopes of getting some nice cyclic gameplay, so we don't have to keep restarting the Tetris tools every time a game ends. So, okay, thanks for joining me. Have a nice day, and we'll see you next time.